And welcome everybody to the Daily Space Weather. If you notice, we've got a new background now. Those stars, that star field in the background you see there, that's actually the Big Dipper. Previously, we had a view of the star field around massive radio galaxy Cygnus A. We've changed that out to add a little bit of variety. Today's Daily Space Weather will be talking about the fact that the coronal mass ejection potential remains, and also the supermassive radio source that we talked about yesterday. I'm your host, Dan. Let's start things out looking at a 304 angstroms view of the sun. And this is the SDO browse data section. We've got, you can see some significant filaments here in a couple different spots. Some filaments there, filaments here, and as I've stated over and over again, we don't need coronal mass. We don't need solar flares or sunspots to see coronal mass ejections. If you're wondering how to view this data, this is on the SDO website. Just head to the Sun Now page and click on AIA/HMI browse data, and you'll be able to find that. Here's another view. This is the colorized magnetogram as well as 171 angstroms. It gives you some great insight into two different aspects of the sun, the magnetic fields, as well as the UV emission spectra of ionized iron. And if you're wondering what's going on in the solar system, there's a diagram. Welcome to February. There's where things will be in 1 week. And we've got roughly a line of planets here in a straight line, which means it's very, very dangerous. It's very scary. It's very spooky. Be scared, be spooked. Here's a chart of the stars. I like to use in-the-sky.org. We're not paid to say that yet. And I like to face my star chart to the south. You can rotate yours around however you like. I'm currently facing the south. I also draw in the ecliptic, which is this yellow line. That's the path that the sun takes across the sky. Just put in your location, and it will show you a star chart. You can even animate the chart if you like. Just bring up the sidebar and press that animate button, and you can animate your star chart if you're interested in when Venus and the sun and so on will rise. Let's go to Lagrange point 5 here to show you what's going on from the perspective of stereo A. So that's where Lagrange point 5 is. And here's the view from stereo A. You can see there's quite a bit of plasma suspended out here. Mainly the part in the north portion of the sun. And again, that could eject at any moment with absolutely no warning. It's part of the reason why we have a channel. And no real forecast there. The 10.7 centimeter radio flux all the way down to 73. So very low levels of solar activity kicking off, or a lack of things kicking off, really. Here is the 1-year chart of the 10.7 centimeter radio flux, and that is the radio output of the outer solar corona. So there it is. That's courtesy solon.info. And there you can see the radio flux progression. For you new viewers, the radio flux is a proportional data set to sunspot number. You can see how similar those charts are there through cycle 24 and all the cycles of radio flux and sunspot number progression. We've got some great Helio viewer movies, as we do most days. As long as the site's up, we'll hook you up. So here's 304 angstroms and a little bit higher resolution. And the filaments that you're seeing on stereo A are these up here. They're all around the North Polar region. And there is some magnetic activity right here. There are also some prominences that we'll show you toward the end of the video. Here it is in 171 angstroms without the colorized magnetogram. And you can see one area of slight magnetic organization there in the north. Allow me to get off screen. One area of magnetic organization right up here. No sunspots. And weak solar activity in general. Show you some extra views here. Here's the North Polar region close up. And here's the south. And there's actually two coronal holes down there. You'll get a better view of those momentarily. Here's a close-up of the filaments in the northwest. And we'll show you the rest of our close-up HelioViewer movies in a couple different wavelengths at the end of the video. Next thing we'll do is take a look at volcanoes. So now that we've seen what's erupting on the sun, let's see what's erupting on the Earth. And just a little background for you viewers out there, new viewers especially. The reason these daily space weather videos exist is because what happened was I noticed that the data that I was looking at didn't match up to what anybody else was looking at on the internet, so I figured I would take the opportunity to share the data sets I was looking at with the rest of the world. So that's why these videos exist, and you may find when you immerse yourself in the data, you may discover things that you weren't even expecting to discover. Science is a rabbit hole, and typically what happens when we do science is that we make observations of nature and we say, how could that be a thing? And oftentimes we end up with answers that we weren't even looking for when we go down the rabbit hole of science. So it's always nice to end up with more questions than you had at the beginning while looking for answers. It's just the way it goes. You have to follow the information. So speaking of information, here's what volcanoes have been erupting over the past 24 hours. Klyuchevskoye on the Kamchatka Peninsula. It's producing a flight level 170 situation above its caldera. Shiveluch, also on the Kamchatka Peninsula, flight level 150 there. Please don't fly your hang glider over the icy peaks of Shiveluch. Sakurajima, a Japanese volcano, erupting, producing a flight level 090. It's a 9,000-foot altitude ash plume. Suwanosejima in the Ryukyu Islands, in the same portion of the world there, exploding. Flight level 040, 4,000-foot ash plume. Popocatépetl, mild explosive activity. No report there on the altitude of the ash plume above it. Sporadic emissions of ash are being emitted from Popocatépetl. Fuego exploding down in Guatemala, 14,000-foot ash plume there. Sangre exploding in Ecuador, as well as Revenador. And those two are producing 22,000 and 15,000-foot plumes of ash. And Sabancaya is reminding us not to pole vault the caldera as it explodes and produces a 24,000-foot plume of ash and fertilizes the soil downwind. Next, looking at earthquakes over the past 24, as the 7, 8, and 9 magnitude earthquake drought continues. We don't see any major quakes. One in a bit of an odd spot here in northern South America, that one in Guyana. That might be the largest of the past 24 also. A 5.7. Also a 5.2 near Greece. Let's go up the list in chronological order. And there's a deep quake in the Japan region. A 4.9 magnitude tremor at 129 kilometers depth. And let's just continue up the list here. I believe that is the largest of the past 24, that 5.7. Let's just take a look at that location, as it's quite inland and pretty much nowhere near a plate boundary. So there's a location of that near the Guyana-Brazil border. And shout out to our viewers from South America. Leave us a comment if you felt the quake, or if your friends felt the quake. And let's go back to the list. Pretty much low levels of earthquake activity here, folks. And earthquake droughts end in earthquakes. Please have an earthquake plan if you're in an earthquake-prone zone. Have a bug-out bag. Know which building facades may collapse if you evacuate the one you're in, especially if you're in an old city. There's a deep quake near the Antarctic and South Pacific plate boundaries. It's actually a three-way boundary there. a very far south quake. There's a location of that near the South Sandwich Islands. Discovered by Captain Cook. Was he cooking up sandwiches when he discovered the islands? Or are the islands known for their hoagies? I don't know. I would invite all of our viewers to check out our website, as we are Alt Tech. Yes, and we are on Alt Tech. You can find our social media links on our homepage. There they are. Let me just check the life of the stream before I move on here. And everything is looking copacetic to me. So again, you can find our social media links there, as well as links to our merch shops. There are now 3 of them: the smAsho merch, the smAsho store, and the Smash store. Also, there's a forum there. Perhaps consider posting something there on the forum. It's all free so far. And we won't censor you, so don't make a fool of yourself. We might berate you online, but we won't censor you, as we believe that the solution to bad speech is more speech, not less. So thanks to our patrons, the true source of funding for the content. We're paid just this side of nothing to make the videos on YouTube. And so we've branched out into all kinds of different income streams to ensure that these videos will continue to exist and be publicly visible thanks to our patrons. What you're funding is our mission, primarily. And our mission is to assist, study, and report on the ongoing formation of a unified theory of physics, to raise the awareness of the general public of the relationship between space weather and Earth effects. Yes, your weather comes from space, folks. To connect and consult with media organizations to multiply our reach. Hence this video, to demonstrate cutting-edge proof-of-concept solutions to problems, to public scientific papers in a multidisciplinary manner, including but not limited to sciences like spectroscopy, chemistry, and the rest listed before you, to assist mankind by advancing the study of predictive phenomenon, to do things like optimize value and reduce risk and liability and save lives and resources and adapt no matter what the adversity is, and to not be ossified in our beliefs, and to treat those who are with love, respect, and inclusion to the scientific discussion, as sometimes it takes a long time for people to catch up with the information, especially at the speed at which it's currently been advancing. Now, this is a Smash stream right now, so wherever you're viewing it, if you're viewing it on BitChute or YouTube, you're viewing it in syndication, as it is being currently streamed live to Twitch. It's twitch.tv/smashamash. They've got a great mobile app. Perhaps consider downloading that. Thanks to our followers over there. Please don't forget to press like and subscribe. Press the notification bell, and we need your help to get the videos out there, so please share them on your social media. If you're an influencer, if you'd like to be on the channel, if you'd like to be interviewed, if you've got a channel that you'd like to plug on the channel, let us know. Drop us a line. We'll consider having you on. And sorry, folks, the video can't continue. And this fire will continue to burn the Smash News Network to the ground until you press like and subscribe. We'll hang out and wait until you share on your Facebook, Twitter, Gab, Minds, Parler, and wherever else you're talking to folks online. Cheers. Feel free to pause the video. We'll be here when you get back. All right, and thanks for doing so. YouTube.com/smashamash. Let's talk cosmology. Are you familiar with the standard model of what makes stars do what stars do? Well, if you're going to try to come up with alternative models, you have to understand the standard model first. And the standard model basically features a nuclear fusion dynamo in which the gravity of the sun's mass presses hydrogen nuclei together until they release massive amounts of energy and form helium. And that's the basis for the sun and all stars' activity. Generation 1 and Generation 2 stars, you're living in a solar system believed to be a Generation 2 solar system, in that there are heavy elements here. And without getting too deep into that, let's talk cosmic rays. Cosmic rays are a super important part of cosmology, and we'll tell you why in a minute. First, let's go over some data. Here's the Apatity and Barentsburg neutron monitors. There's Apatity. Pretty flat over the past 30 days. And there's Barentsburg. Slight downtick over the past 30 days at Barentsburg. Next, we'll look at Athens, Greece. Going a little farther south here, as Apatity and Barentsburg are in the Arctic region. There's Athens. Little uptick at Athens over the past 2 weeks. Mexico City's next. going farther south. Similar uptick in the past 2 weeks there, although flat over the month. That's a 30-day chart. And next we'll look at Oulu, Finland, and 2 Antarctican monitors, which tend to show greatly different data sets. So there's Oulu, Finland. Slight downtick over the past 30 days at Oulu. Here's DOMC Antarctica. Little uptick at DOMC Antarctica over the past 30 days. And there's DOMB Antarctica. Little larger uptick over the past 30 days at DOMB. If you want to follow these yourself, just do a search on a website, on a web search like, DuckDuckGo.com, maybe one that obtains unbiased search results. Just do a search for links to cosmic ray data. You'll find this site. I like it. Now, let me get off the screen again. I made up this graphic specifically because of the cosmological implications of sunspot number progression, which is governed by the solar magnetic fields and cosmic ray flux. As you can see, cosmic ray flux is inversely proportional to sunspot number. Now, it's assumed that the solar magnetic fields are causing more cosmic rays to be weeded out by the magnetosphere at times of solar maximum. Hence, you can see low levels of cosmic ray flux when you see high levels of solar activity. Have you considered the possibility that this correlation is an inverse causation, in that is it possible that cosmic ray flux is actually causing the solar activity and the heliosphere to behave the way it is as opposed to vice versa? The Earth's magnetosphere is driven by inductive processes from protons striking the magnetosphere. What if the sun's solar cycles are driven by galactic protons, interstellar protons striking the heliosphere? It's not completely outside the realm of possibility, folks. And this is why, one of the reasons why we monitor these two things. We are very interested in how the solar cycles, what is the mechanism behind the solar cycles? And it's probably the main area of study on our channel. Now, yesterday, we talked about a supermassive radio source. Some would call it a black hole. I've been referring to, quote, black holes, end quote, as supermassive radio sources since the mid-90s. So the one we looked at yesterday, and you may remember this from our thumbnail if you viewed yesterday's video, we looked at gamma ray burster 110328A, which is also known as Swift J1644449.3 plus 573451. This is a very interesting thing, as this is believed to be a supermassive radio source that has recently consumed, or at least 3.8 billion years ago, consumed a white dwarf. So we don't know what would happen if Sagittarius A star, which is the supermassive radio source at the core of the Milky Way galaxy, consumed a star. But apparently this massive galaxy, at its core, it's believed to have had a tidal disruption event where a star got a little bit too close to the event horizon, or perhaps the the gravitational field, let's just say, of the supermassive radio source, which tore apart the star and consumed it. In any case, this gamma ray burster is super interesting. If you want to read about it, just type in GRB space 110328A, and you'll find the wiki article about it. There are also links there to some other stuff. And this is an interesting object, to say the least. How are we finding all these interesting objects? Well, there's nothing random about it, folks. There's nothing. I'm convinced that there's absolutely nothing random going on. This is what we call divine providence. Let's move on, since the cosmology segment is complete. Next, we'll look at the real-time solar wind. And we saw a little ramp up and ramp down over the past 24 hours there. The real-time solar wind, it reached up to 333 kilometers a second. And now we're back to about 319 kilometers a second. Solar wind density 8.57 protons per cubic centimeter. some recent shifts in the BT-BZ here. The BT being the total field. The BT, that's the white line in the top. The BZ being the orientation. In other words, when you see a BZ in the negative, that means it's south polar. That means the south solar polar field is a larger contributor to the total field, if that makes sense. If you see a positive BZ, that means the north solar polar field is a larger contributor to the BT, the total field. Phi angle is the angle of the incoming protons as those magnetic fields orient those protons as they fly through space. And let's move on to the geospace magnetosphere movies. We show it daily. It's 4 hours of data, courtesy University of Michigan. And since we're unable to see this data in archival form, we show 4 hours of data each day on the daily space weather. And it's pretty steady here. You probably see a slight ramp down on the bow shock side, and indeed you do, as we've seen that little ramp down in the solar wind speed over the past 24 hours. And there you can see that ramping down toward the end of the video. We'll also look at ground magnetic perturbations. Since we're living through a polar excursion, we're interested to see what's going on with the earthly magnetic fields. We've got two north poles. Instead of one, we've got two, one over northern Canada, one over northern Siberia. And the South Pole has left the Antarctic continent entirely and is someplace in the southern Indian Ocean south of Australia. That's 4 hours of data on the magnetic field situation. It's also part of the space weather modeling framework. And we've tweaked the order of our tabs a little bit here. We've sort of put all the magnetic stuff in the same section now. We do occasionally make minor tweaks in the order that we show the information. And I do make some vanishing acts happen. We do make some minor tweaks happen when we see the need for it. Here's the 3-day chart of the GOES magnetometer. And you can see some pretty steep parts of the graph here for you new viewers. The N's and M's refer to noon and midnight local time for the GOES 16 satellite, which makes its measurements at the F ionosphere layer. So looking at some more magnetic data here, here is the polarity of the heliospheric current sheet. It shows you South Pole polarity in red, North Pole polarity in green. And as we forecasted yesterday, the Earth remains in the South Pole current sheet there. You can see the Earth's potential field surface source line in orange. And it could actually suddenly snap across. Keep in mind the data is about an hour and 36 minutes old, and the magnetic environment can change suddenly. Here's a line of sight field plot, which also shows you the poloidal fields in the solar magnetogram. No big changes in the sun's B field shown in blue happening recently. And last but not least, we'll show you the coronal hole plot. And we can expect a coronal hole wind stream in about 2 days from that South Pole-oriented coronal hole there shown in red. Here's the magnetic diagram of the solar corona. The sun's atmosphere is a chaotic place. It shows you open potential field force lines in black or purple, depending on their location, and closed ones in pink. Here's just a diagram of the atmosphere, and you can see that the F layer is around 300 kilometers of altitude. That red F on the right side, that is where the GOES 16 makes its measurements. And here's just another diagram. It shows you where things like GPS satellites are located, the altitudes of the Van Allen belts, the altitude of the International Space Station, which is where you would want to be if you were going into space. Do you want to go into space? Leave us a comment. I proclaimed in 2012 that I will be going into space. I didn't know how, but it's becoming more and more likely. As technology and mankind's interest in space travel advances. We don't see many charging hazards here. In fact, 0 charging hazards. And those charging hazards are based on the electron flux. So here's a 3-day chart of the electron flux. And we reached all the way up to about 5,000 pulse flux units yesterday. Sorry, patrons, I didn't get around to warning you about that. It looks like we're going back into warning levels again here. As you can see, the graph is approaching 1,000 pulse flux units, which is where the warning levels occur. Here's a 1-year chart of the electron flux. That's also Solon.info's data. Holla, Solon.info. Drop me a line. We'll put you on a video. Here's the total electron content forecast. This is basically showing you the inner Van Allen belt. And we expect to see some pretty high levels of flux here. And indeed, we see some nighttime charge-ups around the equator. A little bit anomalous there. I'll let it play through a second time. Also some anomalies there, some significant GPS errors expected over North America and Antarctica. You can see those charge-ups there over places like South America at nighttime when GPS errors are less likely. So here's the electron content forecast. And I and NOAA have both been incorrect the past couple of days here, as we've been forecasting lower levels of electron flux. And those yellow diamonds are the observations, while the green squares are the forecast. Here's a visualization of just the ionosphere. We've actually got the wrong data here. I want to have the whole previous day. Just give that a moment to load there. And this data is provided courtesy of Government of Australia, Bureau of Meteorology. So I'm seeing this for the first time now myself. It's a reaction video. Oh my God. Just kidding, folks. It's looking pretty normal there. At around 300 kilometers altitude. Here's the latest image. That one coming at 11:15 Universal Time. Next, we'll do some meteorological information, as it is a snowy day. It's so snowy, in fact, that we'll be producing more content, as I won't be going to work today. If you're wondering, I have about 5 jobs. Yes. So here are the jet streams of the eastern world. Let me move that a little bit. And check out the funky jet stream flow in this area. It's funky. Come on, planet. Rotate. Here are the jet streams of the Western world. Let me turn that a little bit. There we go. Enough to show most of Europe. And we see extreme meridional jet stream flow here over the Pacific Ocean. A huge divergence. The jet stream crossing the equator twice. As well as some strong jet streams up in the polar region. Strong jet streams there between northeastern Canada and Greenland. And here's the Doppler radar map for the Northeast, as we are currently getting hammered by some of the heaviest bands of this snowstorm right now. The wind was just kicking up pretty violently as I did show prep. And here's the forecast courtesy of windy.com. They've got a great mobile app, by the way. Perhaps check that out. And we're going to advance this till tomorrow. There's the windy.com Euro forecast. That's the Euro forecast model there until 1 p.m. Eastern Time. And I've clicked on the wrong thing there. If you're wondering where we're located in Lehigh Valley, Pennsylvania. And the Euro forecast still forecasting just over 12 inches of snow for here. And we're just going to show you the GFS forecast for when the system is expected to move out. So here we are on Tropical Tidbits. And this is going to show you all the precipitation. So there is a second system about to move in. It looks like it's going to be mostly rain for most of Pennsylvania. And it looks like we're going to continue to have some snow into Wednesday here, at least according to the GFS forecast. Again, that's tropicaltidbits.com. Here's what's going on the cloud layer currently. Let me just make sure that the stream is good to go. And we are good. allow me to re-vanish. So there's the cloud layer. And at nighttime, we use the NASA GOES Interactive Weather Satellite Shortwave Radiation Map. It's 3.9 nanometers radiation. And that system is stagnating. The low is currently over eastern Ohio. You can see that slight bit of counterclockwise rotation there, south of Lake Erie. Here's a better view of that with the water vapor map. And this dry mass of air down here is going to largely be in control of this system moving, and you can see that dry air stagnating. Dry air is more massive than moist air, folks. That's because of the molecular mass of atmospheric nitrogen. N2 is more massive than H2O. So when H2O makes up a significant portion of the atmosphere, it makes the atmosphere less massive. And less massive air is less viscous than massive air. That's why dry air and cold air are largely in control of your weather. That's your meteorology nerd physics lesson for the day. And if you're following YouTube channels that don't understand the physics, stop following them. Follow us instead. Leave us a comment, and we'll do a custom weather forecast just for you. Thanks for tuning in, smAsh team. We've got bonus features. Thanks for not endorsing fraud by watching our channel. Are you accountable? Now that it's 2021, the year of accountability, following last year's 2020 debacle, the year of clarity, are you accountable? Are you promoting fraud on your YouTube channel? Well, since we're not, please press like and subscribe, press the notification bell, and share on your social media. Tell your friends, foes, science noobs, and science pros, because we've got lots of stuff to do, and we need your help spreading the content, as we have not gained the traction that we have expected. So we're going to show you the solar intensity gram, and there it is. Do you see any dark spots? I certainly don't. That's because there are 0 sunspots. Here's the colorized magnetogram and the area to keep an eye on. And when I say eye on, the pun is intentional. It's that area right there. The little bright spot, the most likely spot for a sunspot to occur. And we've got some crown prominences and stuff to show you here, so check this out. First, 193 angstroms. And I don't know what happened with the Earth scale there. It got koofed. The Earth scale got koofed, folks. So yeah, we've got a coronal hole rotating into the Earth-facing zone here. And we can expect a coronal hole wind stream from that in about 4 days. And again, we've got some crown prominences here, so I want to direct your attention to this spot right here. See a little bit of a crown prominence there, and crown prominences are associated with more significant levels of solar activity. Here it is in 211 angstroms. And here's the setting area, a large sunspot that's finally moving fully out of view there in 171 angstroms. It's about time to close this thing out. Thanks for tuning in, folks. Stay tuned for more content coming out today. View our playlist, youtube.com/smashamash/playlists. Visit our websites, visit us on social media. There's exclusive content all over the place. And thanks again, viewers, sincerely. We'll see you next time. Remember, stare at the sun, don't drink, and if you do, don't drive. And if there's a foot of snow, don't drive, unless you've got a truck with snow tires and a lift kit. And since it'll never be now again, welcome to the Neo-Renaissance, and may that solar wind be at your back.